Okay.
Great, thank you.
All right. Well, welcome. It is really bright up here. This is Scott. My name's Paul, and we're going to be your presenters today for our session of connecting warehouse data for overall logistics effectiveness. Can everybody hear okay?
We're good?
Pretty
You can hear
good?
us in the back? Yeah, all right, perfect.
All right, there's
Thumbs
a
up.
lot of noise you can kind of hear
Yeah,
around
right.
here. So, okay, well, we'll get things started. Again? All right, so we've got some, here's our agenda that we've got laid out. We're going to talk about IT, OT. We're going to give you some new acronyms to go home with. We're going to talk a little bit about Industry 4.0. What are they, and how do we put them to work for us? Scott, would you like to kick off with the intro?
Sure, so my name's Scott. I run software for Dematic, so a lot of the software underpinnings that we'll talk about today is my team that builds those for Dematic.
Okay. So we got different roles, which is kind of neat. So Scott's more on the engineering and development with the software. I'm the customer service guy. So I'm the guy that's got to fix all the software. No, I'm the one that works. So I've got a customer service role, and my group is proactive services. And so what we're trying to do is, in my group, we're doing a lot of monitoring, things like this. That's the perspective that I'm going to share with you. So customer service versus kind of the software development. All right, so that's good. We'll move on. All right, so some of the objectives. Think about IT. We'll think about IoT, big data, cloud, analytics, machine learning. These are all big buzzwords and things that are starting to influence our business and our organizations. And so it's a transformation that with all these different technologies coming through, they're going to help us start to understand how we can better look at operational improvement opportunities. Asset, it's kind of, I hear it going on and off. Asset utilization, improved throughput. What about a competitive advantage that it can provide to us? What about system reliability? And just really helping better to have the insight to manage and grow our business.
Yeah, I think the important thing is, and Paul will talk a little bit later about how to start small and ways you can add some business intelligence to your existing operation. I think our overall point is you want to think strategically about the long term, make sure you have the right partners and platform in place. But you can, as long as you know what business problems you're trying to solve, you can start fairly small and incrementally.
Yeah. That's a good point. Good point. Okay, so an introduction to IT, OT, and Industry 4.0. So a little bit about industry. So basically what we're trying to do here is we're trying to pull what is IT, what is OT, what is Industry 4.0. So let me bring that in a little bit. So Industry 4.0 is really more about trying to, should I even go through it? How many is familiar with Industry 4.0? Just maybe I'll see. All right, so we could talk about Industry 1.0, where we started talking about the machine-powered equipment. Industry 2.0, where we started to bring in the assembly line and automate and the manufacturing process. Industry 3.0 was where we start bringing in the robotics and creating more automation. Industry 4.0 is the next step where we're taking information technology, operational technology, taking people, processes, and technology and bringing them all together to work for us. Things that can help us with maintenance, performance, energy management. We start to get analytics from that information and that data. So that's where we're going to go from here. We're going to be using overall logistics effectiveness, another acronym for you, OLE. There's a lot of other acronyms that are similar to this. OEE actually is one that probably most of us have heard in the manufacturing industry.
Who is familiar with that term, OEE, for manufacturing? Few? Okay.
Okay, so that's really good. So it's based on, and the way I remember it is APQ, availability, performance, and quality. So think about what are things that happen in your facility that affect availability. And then take another step, what's performance? What are some performance metrics that you might be interested in? And then if you go to the next one is quality. Now if you take availability metrics times performance metrics times quality metrics, that then rolls up to what we would call your OLE score, or in the manufacturing it would be OEE score.
And I think the importance of that phrase OLE to us is that really trying to connect all of the data in a view of availability, performance, quality for your equipment, but also looking at all of your business operations, right? And having that view to connect those worlds of you've got an equipment OEE, but then you want to look at how are you doing at fulfilling your overall business objectives with your facility. Right?
Yeah, I can give you a really quick example. So if you think about your overall score, your OLE score at the very top, and then you drill down and now you've got your APQ, your availability, performance, quality. Maybe your availability metric score is kind of low. Maybe it's like in the 70s. And you look at your performance and your quality, and those are in the 90s. You're probably going to be interested in seeing what's going into your availability that's driving that particular metric down. So then you can drill down a little further and you can say, well, from availability perspective, we're monitoring our shipping sorter and our merge lanes. And we see that the shipping sorter has a lower availability score than our merge lane. So from there, then we can drill down even further. What are we monitoring at the shipping sorter? We're monitoring the induct motors. And we can see that induct motor 1 has the lowest score. It's in the 20s. So you can see how then that one induct motor, that not being available, rolls up into the overall logistics effectiveness score. And so that score is dynamic and can change as the availability, performance, and quality metric data changes through the day. So connecting the dots. Before the session started, I talked to some of the people in the room and asked about what are some of the challenges, some of the things that we struggle with. And one of the things is there's a lot of data that we're dealing with, a lot of metrics, and really almost so much, what do we do with all of it? And the other challenge is that each of these areas are very functional. So is the maintenance data connected at all to maybe the purchasing for spare parts data? Or is that data connected to the work orders that are created? And what if you could lay these verticals, silos that are vertical, if you could start laying them down and start having this horizontal stream of data flow, now you can start to map business processes into that data flow, and you can have some visibility so that maintenance and purchasing can see, why are we ordering this one part over and over, in the last few months more than normal? And you can start to see, well, I'm having a lot of work orders on this one particular thing, and you start to create some intelligence from that if you can start breaking these silos down and create that horizontal data stream across the organization.
I think the way cloud and data technologies have evolved over the last, I'll say 3-4 years, has made that much more feasible for most companies than it was several years ago. So there's for sure R&D, technology development behind the scenes, but the fundamentals are there with cloud technology that just weren't there a few years ago. So it's much more possible to connect data, as Paul's saying, from multiple sources into kind of a single source of truth, which probably uses the cloud. A few years ago, that was prohibitive and not as feasible for many of us.
Okay, so we can take that data. We're going to get a little more sophisticated now. So I was up on the farm this weekend. We had spring break with my family, and so they're more of a farming family, some mechanics, and I have my slides out. I want to make sure I'm doing okay with my presentation for you guys. And they said, well, what is all this cloud? And you're talking IoT and all these fancy words and things like that. And so it was interesting to kind of share some of that with my family up there. But we talked about how much data we already have with the systems that we have in place today. Well, we can even add in more data. We can add more IoT sensors. We can capture vibration data off of a motor or air pressure off of the airlines. We can do energy utilization. What is a control cabinet's energy utilization? And so now you start to actually take all that information and bring it together, and there's even the intelligent devices, but it's really pulling it all together. And I don't know, one way I've explained it to my in-laws was, think about LinkedIn. If you were to look at my LinkedIn profile, you could see where I have worked, what my education is, who are my contacts. If you were to go to my Facebook, what posts do I like? What about if you looked at my online purchasing history? You could get another whole level depth of information about me versus this, we've met in the hallway, we've talked, where do you work, this type of thing, what do you do? If you could do that with your facility, with your equipment, with your business processes, and really get that depth of data, that's what we're trying to drive here, is to give you that extra insight through the data, that digital version of your system. Okay, so beyond the analytics, one of the other things I've been hearing as we've been talking with a lot of the people on the show today is where do you even start with this journey? There's so much that can be done. We're hearing about the IoT sensors. We're hearing about the predictive maintenance. We're hearing artificial intelligence. Where does that all fit in, and how do we take advantage of that? Where does that journey begin? One way is it can be simple as getting a couple IoT sensors. To be honest, you can get a couple IoT sensors right now and have those up and running and monitoring a motor probably in less than an hour. That's a pretty inexpensive, low-risk entry point to help digitize some of your system, getting some of that in data. But that might not be exactly the right approach. The better approach might be to approach this with a use case. What are some use cases that are important to you that you want to solve? What are some KPIs that are important to your business? And then from there, you can reach into the toolbox, and it might be an IoT sensor that you pull out to help address or work with that problem. It might be machine learning, that's a part of that, but there's a lot of tools in that toolbox. And if you begin with just the tool looking for a problem to solve, that might not yield as much success if you were to identify what the issue is and then use the proper tools in your toolbox to help solve the problem.
Yeah, I think what's important about this slide is a lot of customers that we talk to are right on the bottom left, right? I don't know how many of you are in that state, but a lot of people we talk to simply don't even have a current view of their operation, right? They've got silos of information between different subsystems, automation, labor, stuff coming in from the ERP system. So you got to start, I believe, with the basics, which is getting a focus, as Paul says, focus on what your most critical business problems are, but driven by those priorities, getting a complete view of your operation. I think as you go beyond that, then you can sort of systematically figure out where does additional capabilities really add value to your business, right? Getting more to kind of long-term trending, historical trends, and we talk a lot about predictive analytics, but that really becomes, if you think long-term, rather than getting your operational view in spreadsheets, if you're getting that information through data, right, and thinking about how you manage that data, then you establish a foundation where as you collect more and more of that data, in 6, 12, 8 months, 12 months, you may have enough data where now you can get some predictive modeling in place, right? If you bury that data in different databases and spreadsheets, predictive modeling is theory, it's not something you can actually tackle.
Yeah, I totally agree with that. It starts with the data, you got to get the data, and then from there, you move up this model to, then you get the metrics, and then from the metrics, then you get the intelligence. So you got to start somewhere, and it's okay to start with a couple IoT sensors. It gets you that data, and it gets you started in that journey. All right, so this is going to be about a motor. So working in this industry and in this field a little bit, there's a couple things I think I can get from this slide. So number one, and we talked about you can start simple. Think about a preventive maintenance program within a distribution center. Think about, as part of that preventive maintenance program, what you might have to do. You might inventory your motors, the motor temperatures, the oil levels in the gearboxes for those motors. Now, I don't know if you have hundreds or thousands of these types of assets, but currently it's a manual process that you would have a little clipboard, a thermal scanning gun, and you would just go around the entire building and inventory the motor temperatures. That's a lot of time. It's a manual process, and if you just do that once a month, how value added is that really? If you just recorded that motor temperature today, maybe in 3 weeks before you get to your next cycle of PM, that motor's already in an issue. It's already in a state of problem. So think about adding an IoT sensor to that motor where it's feeding live data 24/7 to a dashboard that's giving you then an alert when action is required versus that manual effort of going around the facility and recording that data. One of these, so we've worked with a lot of customers and other suppliers and that work in this field. And I can tell you that model that I just explained about a preventive maintenance, it can save up to 3 hours of downtime from what we've been studying. If you have a vibration in a motor and the amp sensor on a motor, rather than a motor failing during mid-production, what happens is if a motor fails, the product flow starts to be affected. Somebody might look around and say, what's going on? Something stopped. So then you call your supervisor, then they call the maintenance gets involved. They're looking at where the problem might have occurred. And then by the time you say, hey, there's a motor there, and then by the time you go to spare, get them swapped out, new motor back up and running, there could be a 3 hour, what we're seeing, 3 hour outage. What does 3 hours cost you? What is that 3 hours of, how does that affect your throughput and your performance? So again, that's just another simple way. A couple $100 sensor can really start to give you some immediate return on investment. A lot of value from that. So we'll get a little more here. I'm going to talk about kind of shipping sorter, keep the example simple, but on some of these shipping sorters, there's a sprocket, there's a chain, there's a lot of mechanical components that over time they wear out. There's different package sizes that you might run through that shipping sorter. Larger packages, smaller packages. Then there's the whole package tracking of when do I fire this divert to get a package down to the correct lane. So as the chain starts to age and it starts to get a little longer, I've been corrected that chains don't stretch, but they actually do get a little longer as the mechanical components, the links, start to wear out a little bit. So maybe tracking becomes part of the issue. So you're not diverting all of your packages as accurately as you did day one when the system was brand new. Well, if you start having some of this data on the system, you can actually start to program the system to auto-tune itself. We could even call that self-healing. So as different size packages are coming through at different rates, as the equipment is at a different state, it's older or newer, you can have the system start to teach itself how to adjust and keep that system running optimally. So this one's a little about the real-time data, about the current state. And maybe Scott, you could even jump in a little more on this one. I think this is something that you're pretty familiar with, but it's optimization of our algorithms to adjust dynamic workflows, things like this. Looking at not just the conveyor, not looking at just the operations, not looking at just the maintenance, but really starting to pull that all together for that overall logistics effectiveness, availability again, performance, and quality, tying that all together for the big opportunity.
Yeah, I think the key here is as you start to get access to more data, and Paul gave some examples where you can start kind of very small, a few sensors, few specific pieces of equipment. But as you get more and more of this data flowing, first of all, you can do real-time processing on that data, so you can generate alerts, right? And preventative alerts to say, we believe this equipment is going to fail. Looks like you're going to have an operational bottleneck that you should address. So get that alerting. That's still a manual correction. So you have alerting happening to say an operations supervisor, a maintenance technician needs to go take some action. That's definitely a step in the right direction. When you talk about machine learning, now you get into a state where we're actually feeding that data and that learning directly back in the system that's executing the operation, right? That's where we all want to get to when we're moving in that direction. That's an example of, I think, where the more you think long term about the data you're acquiring and how you're managing it, you can set yourself up for much more advanced applications over time.
Yeah, that's good. Which is kind of here again more of this, right. You know, our basic, where you could start in with just a beacon light flipping on and off when you got a fault condition, you know, all the way up to what we talked about, these self-healing systems where you've got that constant real-time data flow coming in from several sources, giving us the ability to do that self-healing capability. So it's, you know, it is a journey. It's going to take more than, it's not just the new technology that's available. There's a ton of technology. There's a ton of data, but it's really understanding what do you want to do? How do you map these business processes? How do you go from the data to the analytics to the intelligence? And then that's got to drive change. That's the whole reason for doing this, is to improve our capabilities, our efficiency. You can't do it alone. You could try, but I would recommend not trying to do it alone. You don't have to do it all at one time either. It's okay to start simple. You know, we talked again about an IoT sensor on a motor. That's a great place to start. You don't have to get into the PLC code. You don't have to, there's even wireless sensors that are on the market now, where you don't have to run all the cable through your facility. Power supplies, network drops, a lot of these sensors, they have 10-year battery life on them. So it's a quick, easy, low-risk way to start to get data from your system. Start with a roadmap, do some process analysis, build some business cases, and then lead, and then manage the initiatives.
Yeah, I really do think you can't emphasize enough the need to start by asking the right questions, because that we all can get buried in technology and buzzwords, but it really does start with what are the biggest either business problems or opportunities you're trying to address. What questions are you asking to solve those problems? That works backwards then into what data do you need to answer those questions, and you can move along that path in a fairly systematic way while you're getting, as the slide says, get comfortable with the cloud technology. But you don't have to start there, but in parallel get comfortable with the technology ecosystem that you can take advantage of, and then be fairly surgical about how you apply additional pieces of technology to solve your problem, right?
So what we just want to make sure, I guess this is an overview. We're not going to get too much deeper than this, but technology is changing. We're all aware of that. With the technology, and it's changing our opportunities that are available to do new and better things. I think it's within this room, it's all of our responsibility to really understand what is the value that this technology can bring to our business, so that we can begin finding ways to adopt the technology and take advantage of that. You know, we look at e-commerce as definitely having an effect on speed. Everything is now we've got to, you know, have more speed. But what about how there's so much more competition now? And with that competition, what does that do to our margins? And so if there's more competition and if there's less margin to be had, where can we then go for that extra competitive advantage? And technology in these areas is going to allow us to see where within our supply chain that there are opportunities to get more speed, more accuracy, better availability, performance, and quality. Those are, with that data, that's the key. Where do we get the data? Those are some questions to start asking yourself. And we really cruised through this.
We did.
Yeah.
We have time for questions.
We do. And, so at this point, I mean, that was what we had to present. We'd love to hear if you have any questions. We'll do our best to answer. I think even with those questions, it's good to help share with the rest of the people in here. We could maybe learn a little bit from each other. So if anybody would have any questions, we'd love to hear from you. Okay. So cloud.
Yeah, repeat the question.
Yeah, so how do we get comfortable with cloud? I could tell you that You know, when we think about Microsoft Azure as an example of cloud versus, I mean, what's the type of security they put in? They have all these extra layers of security, the types of depth of data that we need. There's so much data. Think about the maintenance of what it would take to manage that data on premise. It's so much, the security of a cloud is so much different today because they have to protect that data, that they have all the different certifications and compliance requirements to protect that data, that the security is completely, it's as good as it can get. Think about if Microsoft were to suddenly have a security breach because of their cloud not working well or keeping your data safe. What we're doing with these sensors is you could take a data sensor, feed it to a gateway, the gateway then takes the data, it's encrypted, sends it to the cloud where it's again encrypted and managed out there. There's also another version you can do. You can take some of the data and you can process it on the edge, they call it, before it goes to the cloud. So rather than pumping motor data every second up to the cloud, all those transactions, that data volume costs something, you can actually filter it out at the edge and say only send data to the cloud when something changes or when there's something that requires some action. And so there's different ways, there's hybrid ways to use the cloud as well.
Is there a specific size company that is best for the system that you're recommending?
Quick question was, is there a specific size company that works best on the system we're recommending? I mean, honestly, I would say the approach that kind of Paul and I presented works for almost any size company, right? Because you can start fairly small with the right partner. I would say the value increases the more you have an operation of some level of complexity where a single supervisor can't just walk around and see what's going on. That's where the value increases, but that's more complexity of the operation than it is size of the business, if that makes sense.
There's businesses that will start with 10 sensors, 10 IoT sensors, $1,000 investment, and you can start. And it could be that small. And then from there, you can now you have the data, now you can start to analyze the data, and then you can start to scale from there as you need.
So give me an example, like a company that starts with 10 sensors, what would they gain?
Question is an example of a company that starts with 10 sensors and what do they gain? Yeah.
Okay, so maybe downtime is a use case that would be important to a particular customer. Could that be, let's just use motor, because a motor is a simple device that you can monitor. So you could put on a vibration sensor, you could put on a temperature sensor, and you could monitor the electrical consumption that motor is using. And then you can start to, and if you had two motors, you could even start to compare those two motors against each other. And so you can look at what's the manufacturer of the motor, and the manufacturer could tell you that normal operating conditions are, it can only go to 110 degrees Fahrenheit. Here's the vibration footprint that it should give off, and then you can start to set up parameters around that. And then if it crosses those parameters, create an alert to that for maintenance activities. But there's another thing too, is that there's a lot of preventive maintenance that takes place, and it's based on the calendar. So every 90 days, we're going to do a preventive maintenance activity on an asset. But what if that asset actually, because of how you use it, doesn't need any attention? Every 6 months is fine. So now you can also get that type of information. So now you're able to maximize the utilization of that asset. So you can also get the predictive part so that you know before it goes down that there's a problem, and so that's good. But you can also find out that I don't have to check on this device or this asset every month. I can actually prolong that and go for 6 months and still be absolutely fine.
Any other questions for the group? Otherwise, we'll be around. We can answer questions one-on-one too. Great. Thanks for your time.
Thank you very much. Thank you.